Hello everyone. In this video, we'll talk about the applications of vectors. So we need to know what is a scalar and the vector quantities. A scalar and the vector quantities, these are some of the characteristics of the physical quantities. The physical quantities are those quantities that can be measured. Example, mass can be measured in kilogram, length can be measured in meter, time can be measured in seconds. So these are example of physical quantities. So among these physical quantities, they can either be a scalar or a vector quantity. Now, so in this video, we talk about the distinguishing of scalar and the vector quantities. Here we will talk about the difference between the scalar and the vector quantities. What are their distinctive features? So let's begin with that, distinguishing between scalar and the vector quantities. We will distinguish these two among them according to their definition, that if the scalar quantities, these are the physical quantities which have magnitude only. These quantities, they have only that magnitude, they don't have the direction. This means that they've only that the occupying amount, but don't show the exact where are they pointing to. So example of such quantities include mass, length, time, area, volume, density, distance, speed, electric current, and the specific capacity. So all these, they don't have a specific direction. Example, mass, you can only measure that is certain amount, like 5 grams or 5 kilograms. It doesn't show exactly the direction. Length, when you talk about length, maybe from point A to B, that means that the length maybe it's 5 meters. So that's actually showing the length. It doesn't show where it goes, maybe at which direction. Time also, you can see that it only measures the time, example in seconds, doesn't show exactly direction. So the scalar quantities, they only talk about their magnitude. When you talk about the vector quantities, these are the physical quantities which have both magnitude and the direction. This means that the vector quantities, they are more compared to the scalar quantities, because the vector quantities have a given direction. They show a certain direction where they are heading to. Example of such vector quantities include displacement. Displacement, this is the distance of from one place to another in a specific direction. Maybe they say that the displacement from A to B, it means that the distance of A from A to a direction of B. So that's what is the displacement. They show the direction. Velocity, we talk about velocity is the velocity means that equals to, velocity is like distance over time, but that distance is we put the displacement. So velocity is the displacement over time. So that's velocity. And the acceleration here means that the acceleration is the increase of speed. So acceleration is equal to change, the rate of change of speed. So all this acceleration, you can see there is a direction of change of speed. Also force, pressure, retardation, and the momentum. All these are the vector quantities. So you can distinguish between the scalar and the vector quantities as that the scalar quantities, they have magnitude only, while the vector quantities have both magnitude and the direction. So this is all for this video. In the next video, we will talk about the adding vectors using graphical methods, and the stating of the triangle and the parallelogram laws of force. We will talk about them more, about what do they mean, how are they acting, in short. So thank you for listening this video. Hopefully it's been well understood. So So please stay tuned to the next video. Thank you.